Mars has fascinated mankind for centuries. Named after the Roman god of war, the red planet is the epitome of an alien celestial body. Its exploration is currently one of the most important projects in the field of modern space travel. A short time ago, NASA's Perseverance rover landed on the surface of the legendary planet. The first high-resolution images sent to Earth by the renowned space agency made our jaws drop. However, given the dust-covered surface of Mars, the assumption could quickly arise that the red planet is a seemingly lifeless celestial body that lacks any geological and volcanic activity. However, as a new sensational discovery from the ranks of astronomers shows, Mars could still be home to more life than experts had previously assumed. This discovery suggests that Mars still possesses active volcanoes. In the following video, we'll reveal what these might be like and how they differ from the Earth. If you like our videos, feel free to support us with a thumbs up. Subscribe to Simply Space and stay tuned for more fascinating videos in the future. Mars. Characteristic coloring and surface structures. One look at the surface of Mars is enough to see why the fourth planet of our solar system has always been nicknamed the Red Planet. The characteristic red color of the celestial body is due to the rich occurrence of iron oxide dust. This substance, colloquially known as rust, covers large parts of the planet's surface and could also be found in its weak atmosphere. Photographs of the Martian surface taken in the past over the course of various space missions show that the planet's hull, which is dotted with craters, has clearly visible traces of earlier tectonics. The result of these tectonic activities can be seen in the deep trenches that dwarf anything comparable in our planetary system. South of the equator, for example, are the Mariner Valleys, which extend about 250 miles, reach up to 4 miles in depth, and are an impressive 430 miles wide. No other known rift system in our galactic neighborhood has such extraordinary values. Experts assume that the imposing furrows on the surface of Mars are the result of great volcanic activity. The extraordinary volcanoes on the red planet fascinate with their inconceivable dimensions. Imposing Martian volcanoes. Let's take a look at the volcanic giant Alba Patera. This natural structure protrudes almost 4 miles above the planet's surface and has a fabulous diameter of more than 745 miles. With these monstrous values, the Alba Patera is the largest volcano in our planetary system. Regarding its size, however, the volcanic giant cannot keep up with Olympus Mons. The Mons towers an incredible 13.6 miles above its dust-covered surroundings. Thanks to this incomparable summit height, Olympus Mons has the title of the highest elevation in our solar system. By comparison, the largest volcano on our planet, Mauna Loa, rises some 2.5 miles above sea level. Together with the part below the sea surface, Mauna Loa has a total size of just over 6 miles, less than half the size of Olympus Mons. That the highest volcano in our solar system could climb such gigantic heights has to be due to the natural conditions of its home planet. And indeed, it is the relatively low gravitational pull on the surface of Mars that spawns such behemoths. If the same conditions prevailed on Mars as on Earth, Olympus Mons would be crushed by its own weight and collapse. Regarding the geological development of the red planet, its volcanoes have always played a significant role. According to unanimous opinion of researchers, the individual Martian volcanoes developed about 3.7 billion to 500 million years ago. Whether the volcanoes on Mars are still active or whether they died out irrevocably millions of years ago is still a matter of debate among scientists. However, a sensational discovery now suggests that the gigantic natural formations on the celestial body are still active today. The significant discovery of the Thyssen meteorite. The scientific community, however, has long lacked any tangible indication that Mars is still both volcanically and geologically active. The Martian-derived Thyssen meteorite, which impacted Earth's surface in 2011, was a significant help to experts studying volcanic activity on the red planet. It was the olivine crystals found in the meteorite that attracted the particular interest of the experts. These crystals can typically only form when exposed to rapidly changing temperature conditions, such as what we find in magma convection flows. Accordingly, the red planet must have been volcanically active when the crystals that were later trapped in the meteorite formed. The problem: the age of the olivine crystals is estimated at about 580 million years. Although the find provides evidence for an earlier active volcanism on Mars, the extent to which this still exists today could not be clarified. Nevertheless, the find represents an outstanding milestone in the research of Martian volcanism. Important findings. In the past, scientists had to rely mainly on theory. Although the external composition of Mars provided important clues, real Martian samples of volcanic origin were rare. The olivine finding, which also occurs in abundance in the Earth's mantle, finally served as a valuable sample that could be used to investigate volcanic activity on the red planet in greater detail. With the help of this find, experts were able to calculate that the Martian mantle had a temperature of about 2,840 degrees Fahrenheit at the time the crystals were formed. This value is comparable to the temperatures that prevailed in our native mantle 4 to 2.5 billion years ago. This circumstance led experts again to the theory that large parts of this original heat could still be underneath in the planet's mantle. Since Mars probably differs significantly from Earth in terms of its plate tectonics, the corresponding temperatures would cool much more slowly than on our blue home planet. The Cerberus-Fosse region. Meanwhile, David Horvath, a scientist at the University of Arizona, provided long-awaited, persuasive arguments in favor of current volcanic activity on the red planet. Together with his team, the scientist took a close look at the Mars region, Elysium Planitia. Like many other areas on the celestial body, this region is crisscrossed by deep fissures that were once formed in the course of volcanic activity. Within the rift system called Cerberus-Fosse, the experts came across a very special fissure that immediately aroused the great interest of the researchers. More detailed investigations revealed that the corresponding rift was formed no more than 200,000 years ago, and its birth may even have occurred only 50,000 years ago. Thus, the rift advances to the youngest known trace of volcanism on Mars. Assuming that the Cerberus-Fosse region is the result of volcanic activity, the comparatively young age suggests that the area could be characterized by active volcanism up to the present day. At first glance, the time span of 200,000 to 50,000 years may sound like half an eternity. However, when placed in the overall galactic context, this time frame represents a relatively recent period. The Cerberus-Fosse region has been examined in the past. At that time, however, experts came to the conclusion that the fissured area had formed 500,000 years ago at the earliest. In essence, these are former lava plains that cooled over time and changed their shape in the process. In order to determine the approximate age of a Martian region, researchers look at the impact holes that can be found in the area. The more meteorite craters a region has, the older it is. Using thermal infrared images provided by the Mars Reconnaissance Orbiter, David Horvath and his team examined the structural nature of the striking fissure in the Cerberus-Fosse area. The researchers were surprised to discover that the structure, which is about 3 miles long and about 10 centimeters deep, has virtually no craters. This indicates that the trench must have been formed relatively recently. The discoveries of the InSight probe. In 2018, NASA's InSight spacecraft landed on the surface of Mars. The lander robot was tasked with using seismic measurement instruments to investigate Martian earthquakes. The InSight spacecraft was set down about 1,050 miles from the Cerberus-Fosse region, where it recorded 2 Mars earthquakes within a year. The tremors undoubtedly originated in the Cerberus-Fosse region, a conspicuous circumstance pointing again to the theory that the red planet is still marked by active volcanism. If one follows the explanations of experts, the presence of volcanic activity could favor other astonishing phenomena. For example, Martian volcanism plays an essential role in the existence of water on the red planet. Volcanic activity would also favor the presence of life forms on Mars. What insights will future Mars missions provide about volcanic activity on the legendary celestial body? We here at Simply Space are eager for future findings. How did you like our video about volcanic activity on Mars? Are you as fascinated by the red planet as we are? Feel free to write us your thoughts, feedback, and suggestions in the comments. Thanks for your interest. Take care, and we'll see you next time.